And so the other thing I've been working on and looking at is whether climate engineering of some kind will work. Are there some measures we can take that would, if we get on a trajectory where we're going up and then coming back down, that we can take the peak off of the warming and the impacts? Is there some way to limit warming in the Arctic for a few decades or put it off in order to make sure you don't have the irreversible losses occur that are going to occur as we lose the Arctic, for example? Well, most of the talk in the media is imitate a volcano, put stratospheric aerosols in, put sulfate aerosols in the stratosphere. That's not where I would go right now. I think I've been looking at trying to take some of these approaches, sulfate aerosols in the troposphere or cloud brightening or some ways of brightening the ocean a little bit, as well as, and try and limit Arctic warming. Now that'll have some beneficial effects elsewhere, it'll cool elsewhere, but really focus on the Arctic. Is there a way to nudge storm tracks? We know that sea surface temperature gradients help steer storm tracks. And so can you use this cloud brightening approach in some areas to affect those gradients, at least in some years? Western Australia says they've been in a drought for 40 years. I'm sorry, it's not a drought. It's a shift in the storm track, essentially off of Australia. This is a new condition. We don't say the Sahara is having a drought. Okay? So they're going to be dramatically changed by the shift in the storm track. Is there some way to shift? There's one storm track that's sensitive to the temperature gradients in the Indian Ocean, in the southern Indian Ocean. Is there a way to shift it so some years they get some precipitation in the storms? Now, it may be drenching rains, and so you go from very dry to very wet, and so maybe you don't want to do it. But are there some ways to address the very worst impacts? Don't take control of the global temperature yet. I'm not sure we know how to do that yet, but don't take control of that, but try and address some specific regional aspects. One of the other things that's really kind of interesting that can warm the Arctic is when icebreakers are used and how they function. If they break through springtime ice that is bright and reflecting sunlight, they will create a dark passage. They will break the ice into smaller pieces so it melts faster. And so that'll allow more solar absorption, more radiation to come in and warm the ocean. On the other hand, if they go through in the fall or the winter and they break up the ice, at that time of the year, the ice is serving as an insulator. It's keeping the heat in the ocean and preventing it from radiating to space. That's why with thick ice, you can get down to minus 40 degrees or so, and yet you have 2 meters down, you have ice, you have water at zero. So ice is an insulator. So if icebreakers go through in the winter, it's hard to go through 2-meter ice, but if you go through the thinner ice, what it will do is let heat escape from the ocean into the atmosphere and then from the atmosphere to space. And as you make the ocean colder, that allows more ice to form sort of later in the season. So that would be a way, for example, to try and encourage ice buildup, just as reducing some of the heating gases or black carbon will tend to reduce the warming influence. So there are people starting to look at what you might be able to do in the Arctic to try and see if we can at least limit it a bit, given how much it is changing.